All right, we're taking a look at a couple more integer exponent rules today. We've already learned a few in class, and so your objective is the same as it has been. I can understand and apply the laws of integer exponents to simplify expressions. So we're going to be talking today about zero and negative exponents. So let's talk first about exponents of zero. It says any non-zero number to the zero power is 1. So it gives you this example here of 5 to the 0 power equals 1. But let's prove it. If you have your calculator, you need to go get it because we're going to be using it throughout the lesson today. So let's pause the video if you don't have a calculator and go get that real quick. And let's test it out. Let's try something on the calculator and see if something to the 0 power equals 1. So let's do 7 to the 0 power. So 7, exponent button, and 0. And yes, it does equal 1. That may seem a little bit strange, but we'll talk more about why that's true in class. For now, just know that that's the rule, and we'll get into more detail in class about why that's true. Try something else. You type something in, just some other number besides what I'm going to type in. I'm going to do like, I don't know, 854. So you try something else, and we'll both do it to the 0 power, and then it equals, and yeah, it really is, it is 1. Anything to the 0 power that's not already 0, a base of 0, is going to give you 1. The other one we're talking about today is negative exponents, and for that one I think it'd be better just to go ahead and drop down and work through our first example problem here. So what we're supposed to do is write with a positive exponent. We're not actually going to do this part over here today, so you guys at all actually, so you guys can cross that out. But we're going to change 5 to the negative third and write it with a positive exponent. It doesn't mean just rewrite 5 to the negative third as 5 to the positive third. Really what it means is write with a positive exponent without changing the value. And 5 to the negative third is not the same as 5 to the positive third. Those two equal two different things. In fact, let's go ahead and figure out what 5 to the negative third equals. Your calculator will do negative exponents. So give yourself a base of 5 raised to the negative third power. And make sure you use the negative button down here with underneath the 3, not a minus. So 5 to the negative third gives you 0.008. So we got to go ahead and write that, 0.008. Okay, that's just for us to know what that equals. We have to come up with a way to write 5 to the negative third with a positive exponent without changing the value here. It still needs to equal 0.008 in the end. So the first step today to change the negative exponents to positive is you want to make sure, go ahead and rewrite 5 to the negative third with me here. You want to make sure that you have it written as a fraction. So you can write anything as a fraction, even powers like this, without changing the value. All you have to do is give them a fraction bar and a denominator of 1, because anything divided by 1 is itself. So giving something a denominator of 1 does not change its value. So go ahead and copy that down underneath step number 2. We've made it into a fraction. But this is really, step number 2 is really how we change a negative to an exponent to a positive one. What you do is you flip the fraction over and you change the sign of the exponent to its opposite. So in this case, because it's negative, it will change to positive. If it was positive, it would change to negative. So flip this over, which means the 1 will now be the numerator, and 5 to the negative third becomes the denominator, but in the process of being flipped over, the negative exponent changes to a positive 1. But remember, it's got to equal 0.008. We had to change it to a positive exponent without changing the value of it. So let's now test out and see, and I want you to type this in too, if 1 over, I'm going to use divided by for my fraction bar. So 1 divided by 5 raised to the third, it is also 0.008. So they come out to equal the same thing. That's good. We wanted to change it to a positive exponent, but not change the value of the number. So go ahead and flip over to the back, and we're going to do a little bit of practice with this. We're going to be doing some different things with negative exponents is what we're going to focus on today. So we're going to start by writing each expression using a positive exponent. So number 1 here is 6 to the negative third power. So we're going to do what we just did through the steps here. First thing is to make sure it's written as a fraction. And then you're going to flip the whole thing over. 1 goes up top. And when you change 6 to the negative third, you change it to the bottom. It becomes 6 to the positive third. And 6 to the negative third and 1 over 6 to the positive third have the same value, just like we did on the other side there with 5 to the negative third. Number 2 is going to have a negative base, negative 4 to the negative fifth. And we're going to change this negative exponent to a positive 1. So again, give yourself a denominator of 1 to write it as a fraction. And then flip the whole thing over. The 1 goes up top. And when we flip this over, notice that it's only the exponent that changes from negative to positive, or changes to the opposite. We didn't change the base when we did this, did we? The 6 still stayed positive 6. So when we flip this over, the negative 4 base will still be negative 4, but the exponent will give us, will change to a positive. So 1 over negative 4 to the fifth. Number 3 is a to the negative second. So this time we have a variable. So this still works even if you have a variable. You're still going to give yourself a denominator of 1 to make it into a fraction. And then you're going to flip the whole thing over. The 1 will go up top. A to the negative second will get sent to the bottom and become a to the positive second. And you flip it over like that. So that's how you can rewrite negative exponents as positive ones. We're going to take things a step further here on 4, 5, and 6, where we're going to actually evaluate negative exponents. So the first one here is 2 to the negative second. So we don't know how, at least without a calculator, to evaluate a negative exponent. So the first thing is going to be to change it to a positive 1. So we're going to follow the same steps we did up here. Again, a denominator of 1 and flip it over. 1 over 2 to the positive second. Then it has a positive exponent. So now we can evaluate this. The 1 will stay up top as your numerator. And 2 to the second power we can evaluate now because we know what a positive 2 times positive 2 would be. It'd be 4. So 1 over 4 is your final answer here. So I want you to notice something on this first one, that negative exponents do not give you negative numbers. Okay? Negative exponents just give you small numbers. 1/4 is less than 1. So usually your negative exponents are going to give you something less than 1. Just like we did on the other side when we evaluated 5 to the negative third on the calculator, it didn't give us a negative number. It gave us a very small number, 0.008. So that's the deal with negative exponents. They don't give you negative numbers. They give you small numbers. So let's go to the second one here, which is 4 to the negative second. So once again, to evaluate this, we have to change the negative exponent to a positive 1. Then we flip it over, 1 over 4 to the positive second. And then, now that this is a positive exponent, we can evaluate it. 1 over 4 squared, or 4 times 4 is 16. So this is 1 over 16. That's your final answer. That's what that looks like evaluated. Number 6 here, the last one to evaluate, is negative 6 to the negative fourth. So again, we're going to give this a denominator of 1 to make it into a fraction. And then flip the whole thing over. 1 over negative 6 to the positive fourth now. So our final answer will be 1 over something. We need to evaluate what negative 6 to the fourth is. So we might need the help of the calculator on this one. So just make sure when you type this in that you use the parentheses here. So we're evaluating in parentheses negative 6, finish off your parentheses, raised to the fourth. And this is our denominator, so it's 1296. That's a really small number. That's 1 out of 1296. It's like if you were to cut a pizza into 1,296 pieces and just take one of them. So it's very tiny. But that's your answer there for what negative 6 to the negative fourth would be. All right, here's where things kind of get a little bit tougher here with negative exponents, because all this is pretty easy. You just give a denominator of 1 and flip it over, and then here we just evaluated those. But on 7, 8, and 9, things are going to get a little bit tougher here. So number 7, it says simplify and express using positive exponents for these. So we have 5 to the negative first times 5 to the negative third. So if you remember our rule on multiplying powers, we keep the base the same, so the base will still be 5, and then we add the exponents together. So we add negative 1 plus negative 3 is negative 4. But we're supposed to express this using positive exponents, and that's a negative. So now we just pick up where we had these, where if it's a negative exponent, you make it into a fraction, and by giving a denominator of 1, and then you flip it over. 1 over 5 to the positive fourth. And because it says express using positive exponent, we don't have to evaluate that. So go ahead and circle that. That's your final answer on number 7. Number 8 is m to the third, n to the negative fourth, times m to the negative first, and then n to the second. So again, this goes back to our rule of multiplying powers, multiply powers. You look for a common base, so m and m to the third and m to the negative first. Keep the base the same and add the exponents together. 3 plus negative 1. That would be positive 2, right? And then we have another base here of n, so write that there, and then add those exponents together. Negative 4 plus 2. Well, there's more negatives than there are positives. In fact, there's 2 more negatives than positives. So your answer will be negative 2. So we have a bit of a problem here in that one of our exponents is positive and the other one is negative. So if we make this into a fraction, like we need to here, to change negatives to positive, we can't flip the whole thing over here. Because if we flip the whole thing over, everything will change to the opposite of what it is. So if we flip it over, then this one will become negative and that one will become positive. And we'll still have one negative, one positive. So if you have one like this, what you need to do is leave whatever is in the numerator as that's positive, leave it there. You don't want to flip that part over. You can be selective here. Just take the power that is negative and move that to the denominator. So we're going to leave m squared up top. The 1, if we flip that over and did 1 times m squared, it would just be m squared anyway. So the 1 kind of gets unnecessary at this point. We don't need it anymore. And n squared, n to the negative second on the denominator becomes n to the positive second. So now both of our exponents are positive. We left this one up here where it was already positive and send that one to the denominator to become positive. So just change where it's at in the fraction to change the sign of it. Okay? Let's try another one kind of like that one. But this one's going to be dividing before we end up with a negative exponent. So number 9 is y to the negative fourth over y to the second. So you know the rule for dividing powers. We keep the base the same, so still be y, and then we subtract the exponents. So negative 4 minus 2. Negative 4 minus 2. So negative 4 minus 2, that's just a bunch of negatives combined to make an even bigger negative number. So it'd be y to the negative sixth. So for this one, because we only have one exponent and it is negative, we can give the denominator of 1 and then flip the whole thing over. 1 over y to the negative sixth becomes y to the positive sixth. So that's it on those. We're going to do some more practice problems when we get to class.